Yeah, welcome back. Let's continue from where we stopped. The next one is number 3, and that's 3a. That's 3a. Solve the equation 3 raised to the power 2x minus 30 times 3 raised to the power x plus 81 equals 0. Now we can write 3 raised to the power 2x as the square of 3 raised to the power x, and that's minus 30 into bracket 3 raised to the power x plus 81 equals 0. And that means now I can make 3 raised to the power x k. Let k be equal to 3 raised to the power x, and the equation becomes k squared minus 30k plus 81 equals 0. Now, can I solve this by the factorization method? That's the same as k squared minus 27k minus 3k plus 81 equals 0. And that's simply k into bracket k minus 27 minus 3 into bracket k minus 27 equals 0, which means k minus 3 times k minus 27 equals 0. And this simply means k minus 3 equals 0, or k minus 27 equals 0, which simply means k equals 3 or k equals 27. But don't forget that what we want to find is x and not k. So that means 3 raised to the power x. Therefore, 3 raised to the power x equals 3, because k is 3 raised to the power x, or 3 raised to the power x equals 27, which means 3 raised to the power x equals 3 raised to the power 1, or 3 raised to the power x equals 3 raised to the power 3. And that therefore means x equals 1 or x equals 3. You know, when bases are the same, you can equate powers. So that's 3a. What's the next? The next one is 3b. Given that log 5 base 3 is equal to 1.465, evaluate without using tables log 25 base 3 plus log 15 base 3. That means log 25 base 3 plus log 15 base 3 will be equal to let's see. Okay, what's the easiest way to do that? I can write this as log 5 raised to the power 2 base 3 plus log 5 times 3 base 3. And that's the same as log 5 raised to the power 2 base 3 is the same as 2 log 5 base 3 plus log 5 times 3 to base 3 is the same as log 5 base 3 plus log 3 base 3. And that's simply 2 log 5 base 3 plus log 5 base 3 is the same as 3 log 5 base 3 plus, and I know that log 3 base 3 is the same as 1, so I can just write 1 So that simply means 3 times 1.465 plus 1. And what's that? 3 times 1.465 plus 1, and that's 5.395. That's 5.395. Very, very simply. There's another method. If you do the right thing, you get the same answer. That's 5.395 simply. Now to, that was 3b Roman figure 1. 3b Roman figure 1. Now to 3b Roman figure 2. Without using tables, evaluate 2 over 3 log 64 plus 4 log 3 plus 4 log 3 plus 1 over 3 log 27 plus 3 log 5 over 3 minus log 18 minus 3 log 10. Now when a base is not written, then it's in base 10. 2 over 3 log 64 is the same as, this is equal to log 64 raised to power 2 over 3, and 4 log 3 is the same as log 3 raised to power 4 plus 1 over 3 log 27 is the same as log 27 raised to power 1 over 3, and 3 log 5 over 3 is the same as, that's plus, is the same as log 5 over 3 raised to power 3 log 5 over 3 raised to power 3 minus log 18 minus 3 log 10 is the same as log 10 raised to power 3. And now the next line is 64 raised to power 2 over 3 is the same as the cube root of 64 raised to power 2, which is 4 raised to power 2, and that's 16. So that will be log 16. 3 raised to power 4 is 81. So that's log 16 plus log 81. We're trying to do it step by step so that we don't get confused. Log 27 raised to power 1 over 3. 27 raised to power 1 over 3 is a cube root of 27, which is 3. So that's plus log 3 plus log, the cube of 5 over 3 is simply the same as 5 raised to power 3, which is 125, over 3 raised to power 3, which is 27, minus log 18 minus log 10 raised to power 3, which is log 1000. And that's going to be equal to, now we can apply the another rule of logarithm, which will now give us log 16 times 81 times 3 times 125 over 27. Yes, write that first. 16 times 81 times 3 times 125 all over 27 divided by, let me write it this way, divided by, the ones that are negative will be division, divided by 18, divided by the product of 18 and 1000. So divided by 18 times 1000 that way, and that will be equal to, so what does this give us? First of all, we can cancel this. 27 here 1, 27 here 3. So that simply means log 16 times 3 times 3 times 125 over 18 times 1000. I think that's an exact number. Let's check. 16 times 3 times 3, 16 times 3 times 3 times 125 divided by 18 divided by 1000, and that's just 1. So that's simply log 1, and log 1 to any base is 0 because the base is 10. Of course, we know that. So that's equal to 0. The log of 1 to any base is 0, and the final answer is 0. That's it. Very, very, very simply. Now let me do number 4. Let's go to number 4a quickly. Solve for x, giving your answer correct to 3 significant figures if 2 log x base 10, the base is even given here, plus 3 log 5 base 10. Let me write that on a single line. Plus 3 log 5 base 10 equals 2. Find the value of x correct to 3 significant figures. First of all, this is the same as log x squared base 10. Before you can combine the logarithms, you must make sure that the coefficients of the logarithms are 1s, plus 3 log 5 base 10 is the same as log 5 raised to power 3 base 10, and that's equal to 2. Now I can combine the logarithms as log x squared times 5 raised to power 3 base 10 equals 2, and this is the same as log 125x squared base 10 equals 2. Now if I write the logarithmic equation in index form, I'm going to have 125x squared equals 10 raised to power 2, and that's the same as 125x squared equals 100. Now if I divide both sides by 125, that will mean x squared equals 100 divided by 125 is 0.8. How about correct? Yes. So x is therefore the square root of 0.8, which is equal to, let's see that, square root of 0.8. That's 0.8944. But they said we should give our answer correct to 3 significant figures, and that's going to be 0.894 to 3SF. And that's it. Very, 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 very simply. Alright, so the very last one, which is 4b, given the log 2 base 10 is equal to 0.3010 and log 3 base 10 is equal to 0.4771. Calculate without using tables the value of log 0.72. Log 0.72 is the same as log 72. Log 0.72 base 10 rather is the same as log 72 over 100 base 10, and that's equal to what can we do here? Okay, we can say 4 here 18 and 4 here 25. So that's the same as log 18 over 25 base 10, which is equal to log, they only gave us, okay, they gave us log 2 and log 3. I think they should have given us log 5. Let's see. This is the same as log 18 base 10 minus log 25 base 10. Remember that rule? Log p over q to base 10 is the same as log p base q. Log p over q to base b is the same as log p base b minus log q base b. So that's a rule I'm applying here. Now this simply means log 18 is the same as 9 times 2. So I'm going to say log 9 times 2 base 10 minus log 5 raised to the power 2 base 10, which simply means log 9 base 10 plus log 2 base 10 minus 2 log 5 base 10. And that's the same as 9 is 3 raised to the power 2. Well, let me write it so you don't get confused. Log 3 raised to the power 2 base 10 plus log 2 base 10 minus 2 log 5 base 10. And finally, this is the same as 2 log 3 base 10 plus log 2 base 10 minus 2 log 5 base 10. And that's going to be log 3 base 10 is 0.4771. So that's 2 times 0.4771 plus log 2 base 10 is 0.3010 minus, we don't have log 5 base 10 unfortunately, so I'm just going to leave that as it is, 2 log 5 base 10, and that's going to be equal to, let's do that, 2 times 0.4771 plus 0.3010, and that's equal to 1.2552 minus 2 log, it's probably, I'm sure it was probably due to an omission that log 5 base 10 was not given, but this is the best, this is the farthest you can go, and you stop there, then you get the full mark. And that's it, very, very simply. Thank you very much, and I'll see you in the next. Take care and catch you later. Bye bye.